Good morning, everybody, and welcome to Norwegian Museum of Mining and the 24th Kongsberg seminar. And particularly welcome, of course, to the invited speakers. Some of you have traveled far to get here, and we greatly look forward to your presentations. As usual, the Kongsberg seminar is cross-disciplinary, and this year we have people from the different branches of earth sciences, and we have physicists, and we have people approaching science from a field-based point of view. Some are experimentalists, and others are numerical modelers, and even theoreticians. And the idea here is, of course, then to shed some light on geological processes through cross-fertilization and communication, and therefore we also have allocated ample time for discussions after every second or third talk. So I encourage you to take part in these discussions, and let's try to keep this atmosphere as informal as possible. Well, the visitors will see that most of the participants have this name badge with the PGP as a host organization, and this is PGP is Physics of Geological Processes. It's a Norwegian Center of Excellence that was started in 2003. It's one of the first 13 Norwegian Centers of Excellence. It's a physics geology project. We have currently about 60 people, including 20 to 25 students from 16 different nations. And through the posters, you will get some impression about the different kinds of activities taking place in the PGP. So we will now soon start with a sort of formal part of the conference, the talks. But before that, just have a little look at the cover of the abstract volume. And many of you will recognize the great wave of Kanagawa that was made by Okusai in 1831. Was a series, one in a series of 36 views of Mount Fuji, the name of the series of images. And I like this image also because it sort of portrays some sort of an understanding of connection here between the mountain and the wave, between the geosphere and the hydrosphere, and it also clearly illustrates the challenges that we as humans sometimes faces within this sometimes violent nature. And I also like the way he portrays the wave here. Clearly is aware of that the geometry of this wave has complexities on different scales. Big wave, and there are smaller waves, and perhaps even smaller wavelets. So clearly he saw the fractal geometry of nature about 150 years before models brought on the fractal geometry of nature. So, what about the title, or Earth Systems Challenges? To some of my colleagues also, I suppose, this title might sound a little bit populistic, but I think the Earth Systems way of thinking about and the concept introduced in Earth System Sciences is a fruitful and established way of thinking about the complex patterns and processes of the Earth. And how the Earth develops. It's quite well established now, and as you can see from serious scientific books, and even there is a Journal of Earth System Sciences, California Journal of Education here, with a history on Earth System Sciences. It's becoming clearer and clearer to us how the different processes of the Earth are coupled and connected to make the Earth patterns, and how the actions of the geosphere is interlinked with the actions of the hydrosphere, atmosphere, biosphere, lithosphere, and cryosphere, and in a troposphere, you don't like to stick yourself into the biosphere part. Where's the deep Earth? Deep Earth is part of the geosphere, it's inside here. So, what are the challenges of the Earth System Sciences? So, of course, these challenges depend, the answer depends on who you actually ask. PGP has sometimes been criticized for not really facing the big problems in earth sciences. But you also have to remember then that we're not just earth sciences, we're a cross-disciplinary physics geology center. So it's important for us to deal with problems that can be addressed in a physics-like way too. So we need a certain ability to constrain and characterize our system to be able to address them both from an experimental, theoretical, and from a field-based viewpoint. So sometimes problems like, say, Why did the Earth get plate tectonics? When did it happen? What drives plate tectonics? How did the Earth crust form? Random questions, no doubt about that. Sometimes they are a bit complex for us as a mixture of physicists and geologists to address in a quantitative way. But what we hope when we address systems that can actually produce complexity too, but are more constrained, is that if we understand systems at a fundamental level, so that we actually, for example, can use time, not just in time in the past and say something general about what happened in the past, we can also turn time into the future and be in some cases able to predict what will happen in our geological system in the future, or say something about whether it's possible to predict what will happen in the future. So this kind of sciences, I think, clearly would also be relevant to help addressing some of the current global problems when it comes to energy and environment, water resources, and so on. But I leave it then to the speakers to define themselves what they think are the most important challenges in our system sciences at the moment. And so we will go on to the first lecture, the Rosenquist lecture, which is named after Professor Ivan Rosenquist. He became professor at the University of Oslo in geology in 1960. He retired in 1986, I think. He died in 1994. He was quite a character. He was very controversial, cross-disciplinary. He was did his first degree in chemistry. He applied his science throughout his career. Particularly, he was involved in marine clays and the stability of clays and the problem with clays that would start to float when you disturbed it. It was a problem during road making. It represented the geohazard that he once became famous because he was on the television and he salt with the clay and it got stiff and rigid again and he could walk on it. Fascinating for the public to see that the scientists could actually do something that was important to the rest of the world. He also was, during the war, he worked in the Norwegian resistance and he was arrested, accused for espionage and sentenced to death and put in jail in Oslo. He wasn't executed because the current Nazi-friendly rector of the University of Oslo decided that he should have a chance to finish his PhD, because he had a very promising start with his PhD, so he got a microscope to his jail cell and his field notes. And so he was working on his PhD on death row, so to speak. If I were him, I would have worked very slowly. He actually finished the work in 1944, I think. Then he was pardoned and sent to Sachsenhausen. So he was never executed, as we all know. And when the war ended, then he had his dissertation in 1945. So being able to do research at a high level within on death row in a camp in Oslo is quite impressive. So we chose to name this. I happen to have his chair as well as Professor Petrology. So I thought it would be a good idea to name this first lecture at the Kongsberg seminars after Ivan Rosenquist. And so far we have had 10 distinguished Rosenquist lectures, starting with a physicist, Per Bach, working at Imperial College, then now. And then last year, then with another physicist, Nigel Goldenfeld, an Englishman working in Illinois at the Topical campaign. And in between, there were 5 distinguished American geophysicists, biologist Lynmore Lewis from Amherst College, chief biogeochemist Jill Banfield, and in 2009, petroleum geologist or organic geochemist Marcia Mello from Petroleum Industry. And this year, we're happy to have a Europe-based researcher. It's the first since Per Bach. And this is, as you know, Steve Sparks, who will tell us about volcanoes and their impact on society. I met Steve first when I was a postdoc in Bristol in 1991. Steve came to 1991 as a professor in 1989, I think. I wasn't working in Steve's lab, but I was very impressed by the combination of approaches, both experimental and numerical approaches, to volcanic processes, and also coupled to a very thorough field-based activity. So this combination of approaches is sort of a philosophy that we have tried to adopt at PGP, and I think this is a very fruitful way of approaching the complexity of natural systems. So Steve's background, he has a PhD from Imperial College in geology in 1974. And then I think you were on a NATO fellowship in America, Rhode Island, before you started as a lecturer at Cambridge in '76. According to what I read, and stay there until you got the professorship in Bristol. So Steve is, of course, he had many awards. He's a fellow of the Royal Society. He's a fellow of the American Geological Union, and he's also president of the BGP, I think it's called, Volcanology, Geochemistry, and Petrology section of American Geological Union. He has received a number of awards, including the Arthur Day Medal of the Geological Society of America and the Arthur Holmes Medal of the European Geoscience Union. He's a so-called CBE, Commander of the Order of the British Empire. And with around 300 papers and an H index of 64 and 32 papers cited more than 100 times, he's the highest cited scientist in volcanology worldwide according to the Thomson IC database. So we're very proud to have you here, and we greatly look forward to your presentations.